Hi, I am Harshil Jain from Group 2 and this is my ELP project on op-amps. Origin of op-amps. The first op-amp device was made in 1941 by Carl D. Schwartzel Jr. of Bell Labs. It was a vacuum tube op-amp, an op-amp designed as a general-purpose DC-coupled high-gain inverting feedback amplifier known as summing amplifier. So, what is an op-amp? An operational amplifier or op-amp is a DC-coupled high-gain electronic voltage amplifier with a differential input and usually a single-ended output. In this configuration, an op-amp produces an output potential relative to the circuit ground that is typically 100,000 times larger than the potential difference between its input terminals, though it can be regulated according to the needs of the user. Operational amplifiers had their origins in analog computers, where they were used to perform mathematical operations in linear, nonlinear, and frequency-dependent circuits. So, why are they so popular? Op-amps can be used for various applications depending on the external components added. In the most basic circuit, op-amps are used as voltage amplifiers for devices like speakers, microphones, receivers, etc. Op-amps are also used as differential amplifiers, integrator circuits, etc. Op-amps are widely used for various applications, and it is no exaggeration to say that op-amps are found in almost all electrical appliances. Working of an operational amplifier. Your V1 is the inverting input, V2 non-inverting input, and A is the magnitude of voltage gain, which is ratio of the output and input voltages or the ratio of output and input impedances. For a basic inverting non-inverting op-amp, the current flowing in output circuit is same as the input. Now, since the output voltage is proportional to the output resistance, which is much more than the input resistance, the gain ratio is also large and the input signal is amplified. Different uses of op-amps. Differential amplifier is the first use. Here, the difference between the input voltages V2 and V1 is amplified with the ratio of the resistances as the output voltage. The differential amplifiers are used mainly to suppress noise. There are two main causes of this common mode noise. Noise generated in wires due to electromagnetic induction, which causes a difference in potential between the signal source ground and the circuit ground, and current flowing into the ground of the circuit and from the another circuit causes a ground potential rise, which is also noise. Inverting amplifiers. Here the input voltage is reversed in sign and magnified by the ratio of the resistances. It is practically used in integration applications. The op-amp based inverting circuits are more stable, distortion is fairly lower, and provide a superior transitory response. They are also used in analog filtering and signal processing. They are also used in various fields like communications, process control, displays, computers, measuring systems, power sources, and signal sources. Non-inverting amplifiers. Here the sign of the input voltages is not changed and is magnified by proportional to the ratio of the resistances. Non-inverting op-amp are used in various applications such as non-inverting adder, filter circuits, buffers, programmable gain amplifiers, clippers, and signal conditioning circuits. Some other common uses include summing amplifiers, which returns the sum of the voltages as the output voltage. It is used in audio mixers to combine various signals from channels. Inverting integrator, it returns an output proportional to the integral of the input. It is used in solving differential equations in analog to digital converters and in various wave shaping circuits. Other uses also include voltage follower, instrumentation amplifier, Wein bridge oscillator, active filters, comparators, inductance gyrator, negative impedance converter, precision rectifier, and exponential output.